Okay, hello all. I am William. I am the maintainer of Sub. I work for Blue Robotics. And I'm also the guy behind lot.ardpilot.org. Today I'm going to talk actually about BlueOS, just talk kind of a sales pitch today. And I'm not going too deep into the technical implementation, just showing why it's nice and what it makes it easier for both users and developers. So yeah, let's start with a brief summary. First, a refresher, why we actually created BlueOS. So then I'm going to say what it looks like now. I'm going to show you some pictures. I'm going to say who's our target market, do a brief systems overview. I'm going to go into details and at what it makes easier. And then I'm just going to talk a bit about the roadmap, what we did recently, what's coming next, and how you guys can try it. Okay, so why was it created? We work a lot with subs, and they rely a lot on the onboard computer because, well, we can't do radio underwater. So usually we have a tethered link. We use it for video streaming, managing the autopilot for flashing, getting logs, getting Mavlink through. We also require it for lots of sensors. Lots of these sensors are not even talking to the autopilot, like sonars. And they also can have a lot of bandwidth. Okay. Our old companion was forked from Ardupilot companion, which I think has been also archived for a while. And our integrators did an ecosystem where they can kind of work better, so they don't have to fork our system to do customizations, and they can easily build on top of it. Okay, so this is what it looks like now. We have a nice looking sidebar, vehicle overview. We have an extension system with plenty of extensions already. We have system tools for seeing CPU usage. We have a vehicle setup page where you can configure lots of parameters in an easy way, lots of also troubleshooting and debugging tools. Okay, next, who is our target market? So our target market is people who want to do things, more advanced things where they actually need these sensors, these more video screens. They want to interface with some custom hardware that's not talking our standard drone CAN and PWM stuff. It does assume a vehicle with a Linux-based companion computer. We are usually building on top of Raspbian, Raspberry Pi OS, sorry. But we also support to some extent x86-64 and some other boards. We are working on expanding that to have support like NVIDIA boards with some better computing powers. And yeah, as I mentioned before, it's useful for interfacing some more complex systems. Okay, so just the overview. This is our basic system, the one you have on the boat. It's just a Raspberry and a Raspberry Pi hat, which is our navigator. But Pixhawk would work just fine as well. We also have lots of users still on Pixhawk. So what's our approach like? We went with a containerized approach that kind of separates things, so we don't have as many conflicts, and things can live more independently. We can also control hardware resources access, so we can limit CPU usage of third-party tools so they don't interfere with critical systems. On the other hand, we have some nice web interfaces and APIs. Our services have Swagger APIs where you have a nice UI. You can look at all the API endpoints and what they do, what you need to pass to them. And we have the extension management for actually adding some new functionality, building on top without having to fork or anything weird. Okay, our front end is built on modern web tools. We're using Vue, TypeScript. We rely currently on Mavlink to REST for passing data through. It just transparently translates Mavlink into JSON, so it's very nice to consume on the front end. We'll soon be moving probably to Maven server, which is going to be on a talk tomorrow. On the back end, we are also trying to use modern technology. So we are currently on Python 3.11. We use Rust for some critical services. And we currently support 3 different routers, with Maven server being the latest one, again, tomorrow. So this is, again, part of the overview, just how things are structured. We have 2 main Docker containers. We decided to keep our car services on the same container just for cohesion. And then we have a bootstrap, which just kind of a simplified supervisor, just makes sure everything's all right. And then all the extensions live on their own containers alongside it. And this is our front end. It's nice. Okay, so what does BlueOS actually make easier? I'm going to talk a bit about each of these points. So it's basically vehicle setup. We have been working a lot on making things simple. It helps a lot with IP-based communications. We were doing it before it was cool and yep. It's great for integrating external tools, and it's also very nice for development and testing. So this is our current vehicle setup page. These are our vehicles, but you can add your custom 3D model just as easily. So yeah, these are actually latest additions. So we now have a motor test. When you highlight one of the motors, it actually shows you on the frame, because we had representing this in 2D is a bit more confusing when you have 8 thrusters, and yeah, you get the point. This is just to help users understand better the system. We recently added lots of sensor calibrations, so we can now calibrate pretty much everything. There's 1 or 2 things missing. The largest work was compass. I have been fighting against compasses for a while now with the dreadful yaw drift. So I ended up making this heading indicator. It can show you the heading from each individual sensor, including GPS now. So it has the heading for the EKF, each individual sensor, like each individual IMU, and then also the GPSs. So yeah, we recently just added setup for fail-safes as well, because, well, sub-users don't use that as much, and we're trying to change that. This, by the way, this is actually vehicle agnostic. If you open rover or copter, you will see the right fail-safes. We recently added some basic gimbal setup, just setting up ranges, maximum angles, and then we have the field of view, so we can easily map that to a virtual horizon on our GCS. Well, I talked about Mavlink to REST. This is basically what it looks like. It can show you all the data in a nice JSON. It can also show live data as it comes through in the browser. And moving on, so IP-based communications. Well, that's easy. If you have a USB 4G modem, you can just plug it in and it should just work. Another thing that's very nice is we have a VPN extension for 0-tier. I was just developing on my Raspberry Pi at home from there, so it's super useful. For Ethernet devices, we have many of those in our ecosystem. The DVL, the first one on the left here, it's a Doppler velocity logger. It's kind of an odometer sensor. It measures velocity underwater very precisely. So you can use that because you don't have GPS underwater. I mean, let's not go there. There is, but not the same GPS. This here is a side scan sensor. So it's not relevant for the autopilot, but it's very nice for rescue missions or when you're trying to find something. Oh, and this is a bolt from one of our engineers with an Starlink. Again, very plug and play. He actually used the Wi-Fi. So yeah. Okay, next. Another cool thing this allows us to do is, well, basically same thing Tweed was talking before. We can easily bridge UDP and serial, connect things. We're going to plug a serial device to your Pi and then program it remotely from your computer. You can also just get data through. If you're using Linux, you can actually just attach the UDP device directly to your autopilot process. So you don't have, you can skip a step basically. It's very nice. If you have a fancy GPS with NMEA output, you can just pipe that straight into autopilot. It thinks it's a serial device. And we can do more. We also have a virtual here extension. Virtual here is a software that allows you to plug devices into a computer and then use them on another as if it was there. So you can easily just program an Arduino board remotely. So you plug an Arduino into your Pi, into your vehicle, and then you can program it remotely. It's nice. Okay, I'm gonna skip this one. And some examples of integrating external tools. One of the extensions we have is for integrating the LCD camera, it's kind of an example. It just exposes both of the video streams that we choose to do, which is the depth perception and then the RGB. We have integrations for multiple kinds of sonars now. As I mentioned, the DVL and underwater GPS system, we can easily make data loggers. We can easily integrate environmental sensors, like for water quality. There's some people working on a hydrophone extension. And then we have a Node-RED extension, which is kind of no-code, low-code tool. And one of our engineers, the one with the boat, actually used Node-RED to expose data from both his solar panel charger and from his 4G modem into the Mavlink stream. So you can know what's happening very easily. It just shows you in our widgets, like what's the signal quality and what power is being generated by the solar panel. That's going to be on the cockpit talk probably in 2 days. Okay, and how does BlueOS help with development and testing? So you can now upload it directly to the autopilot, also remotely from WAF. You can just do /WAF -- upload BlueOS, I think. It has GDB server built in, so if you're doing Linux, which all the cool kids are, you can easily attach GDB and debug. It has a terminal, a file browser, system information tab. I have a local version of log viewer there. Well, the map's not going to work if you don't have internet, but you can see all the other stuff. There are multiple extensions we have that are very useful for development. You have a web-based version of VS Code running on the companion computer itself. We have Jupyter notebooks, so you can easily test things like interactively. Well, Node-RED I mentioned, it's a Swiss knife. We have a Navigator web assistant that's useful for interfacing with Navigator if you're using one of those. So we have all the libraries for all the sensors, very easy to access. Okay. And about extensions, if you don't want to use RStar, you can easily just add an external URL for your own. So no one's tied to us. Yeah, this is an interface for our services. All the services have this UI showing how the API works. You can also test the API. It's very useful even for us who have been working with BlueOS for a while. Oh, these are probed. So we just check for open TCP ports and check if they talk HTTP and they have the expected structure there. Okay, now next section, what's new? Well, we now have a startup wizard. Vehicle setup I just showed you. We're almost merging my FTP support. I'm gonna go into details about most of this. So we have the routers. We just got Pi 5 support in. We have been improving the extension system. Our new GCS now comes pre-installed, cockpit. Again, last day of the conference, you'll know about it more. And we also have a GitHub action now to actually help the whole extension deployment thing. So this is what our setup wizard currently looks like. You can see we may be a bit focused on boats and ROVs, but it's very easy to just do something else and add copters and planes here. This allows you to also load default parameter sets and default LUA scripts. For MapFTP, we now integrate it seamlessly with the Py's file system. So you can just use BlueOS file browser to see all the logs and eventually edit the scripts. Due to how MapFTP is done, the communication is not symmetric, so writing is different than reading, so it's gonna need a layer there, but yeah, we'll get there. So we'll be able to edit scripts even in pixels directly via the file browser. You can already do this with Navigator because it's actually using the same file system since it's a Linux process. So yeah, for the Pi 5 support, we can now run it. We also have to update it to use it 64-bit images. Some systems are already ditching 32-bit support, so we had to go forward. Yeah, the performance of the Pi 5 is great. The 3% is also running ArduPilot. So it's BlueOS plus ArduPilot. Our extension management is looking sleeker now. We've done a bunch of improvements on UI and how things look. Yeah, this is the GCS that's going to be shipped with it. It's turning out very nicely. Again, no spoilers. Well, that was a spoiler. But yeah, and lots of our things are now in a new repository, let's say, GitHub organization. We call it BlueOS community, all things that we're just trying to separate core Blue Robotics stuff from actually things that are more valuable for the community. This includes the BlueOS section. Most of our extensions that were made by us, but yeah. We have lots of open source tools and extensions. We also have a Discord link here if anyone wants to join and ask questions, try something if you need any help. We also have a forum category in our Discuss, which is not ArduPilots, but if you click sub, you'll get there. Okay, so some in-progress features. We're working on actually having onboard video and audio recording. We are also working on some cloud integration for it will allow you remote piloting, which is already working. Yeah, backing up logs and video when the vehicle is online, backing up setting and parameters for creating profiles. So you can easily, if you lost your vehicle for some reason and you want to have just set up a new one exactly the same, you can just load everything back. And this will allow you the idea is to make setup easier so you don't have to go through everything again, just save everything and load into a new vehicle. And yeah, there's also some work to be done still on the vehicle setup. Some calibrations are missing. We want to make easier to use relays, grippers, switching EKF sources, adding further GPS settings, and the list goes on. It's going to be a constant battle just trying to keep up with ArduPilots down there. And okay, and we also have those features are actually, yeah, those are being worked on. And these are the actual planned ones. So we want to, the main page, we want to make into an actual dashboard where you can show some overviews of everything. Instead of just having the vehicle overview, which I showed earlier, we can have, well, yeah, instead of just having this, the idea is to be able to customize it and show it whatever you want here. Yeah, we are also looking into pub/sub architectures. We have been looking a lot into Zeno, which I know, yeah. We're just trying to make it easier to services to talk to each other and kind of simplify the whole data pipeline. We also really need to get video and log synchronization and playback done, so you can, if you're scrubbing a video, you can see all the data there instead of just the video. Yeah, we're also working on supporting more boards, like as other Pi favors and some NVIDIA boards. And we always need some more debugging, logging, and troubleshooting tools. Okay. So yeah, BlueOS has been extensively used on ROVs and boats with Arduino rover, like that are there. We want more people to use it. So we would really love some feedback, especially for other vehicle types. And we are willing to assist in integrating some new hardware, some new vehicles. So give us a shout out if you are working on that. So yeah, you can just try it. You just need a Raspberry Pi. Oh, if you don't have a Pixhawk or a navigator connected, it can also run Zero on the Pi. So you really just need a Raspberry Pi. So everything is on GitHub. You can download images there. Before the questions, I just want to thank everyone in our pilot because it's a great team project and very nice ecosystem. Blue Robotics for actually embracing open source, which is very nice. Elliot and the rest of the software team because they helped a lot with this slides. So yeah, questions?
I never asked William, but how would you add a new vehicle on the vehicle setup there? Like, what is the process of having, for example, the 3D stuff there?
Yeah, the 3D stuff is not nice, very straightforward, but it's documented. You just have to make a file with basically make a file system tree with the model in the right place and the metadata on the right place, and then you place it in a given folder using the file browser. So you just need some files in the right place and it can override everything.
Hello, thank you for a great presentation. It's really interesting to see all the features that you have. A bit along the same lines, like how if you would run BlueOS on a Raspberry for a plane, for example, what are the sort of is that possible today or?
Yes, you and your flight controller. Yeah.
Is it possible to run other containers alongside
Definitely,
BlueOS
yes.
also?
Yeah. Yes. Our extensions are containers. So ideally, to have a nice interface, you would make it into a container, but you don't have make it into an extension. Sorry, but you don't have to. And if you provide the given endpoints, it will even show on the sidebar your UI. So yeah.
Okay, cool. Thank you.
It is. Yes.
すいません。よろしくお願いします。ベース OS の更新をするときはどのようにする、ファイル転送ではできないと思うんですけども、どのようにするのでしょうか。ラズベリーパイのベース OS、アップデート。
How do you update the BlueOS itself? I think is the question.
BlueOS itself? BlueOS itself is very easy to update. I didn't cover this in this meeting, but BlueOS itself has a version chooser. Oh. So yeah, let's hope this works. This is my BlueOS running at home in Brazil. And this is how you change versions. You come here. Oh yeah, all branches I push to GitHub show us versions. But yeah, you can just come here. You can push the remote you want. So if I do Blue Robotics, it's gonna get our official versions, and then you can just come here and click here. And that's it. You just wait. You can see it's just downloading a new container, updated container.
理解しました。ありがとうございます。
Any other questions? So yeah, updating is easy. This is one of the issues we had before with our old companion.
Okay.
Thank you so much. Thank you.